Right, let's go ahead and get started on chapter number 5. Chapter number 5 is in the right place. Almost all the textbooks have been using for last 20 plus years. This is where we discuss modules, and modules have different names, and I'll be highlighting all these names a little bit later. But this is the right place because we have discussed the control structures. In chapter 3, we talked about selection of conditional control structures. Then we transitioned to chapter 4, where we talked about the loops or repetition control structures. So this is the right place to discuss what do we do with modules and how to implement those modules. So in this chapter, we'll talk about just the introduction to modules and how to create or define and call a module and what are the local variables, how do you pass the arguments, parameters to modules, global variables, which I really dislike, but we'll talk about global variables, global constants, and the implementation of these concepts in these three respective languages. So what is a module? Module is a group of statements, one or more statements that exist for the purpose of performing a specific task within a program. So module is basically you break it down, a complex problem, a complex task into smaller tasks. And you can break it down and you can make it a separate set of statements. And then you can call those statements whenever you need them. So most of the programs we are talking about industry wide, they're very large, maybe thousands, tens of thousands, maybe sometimes hundreds of thousands of lines of code. So what we do, we break those into smaller subtasks. So if your task is very large, let's say you want to um, uh, get create a system for a customer for customer purchases. So within customer purchases, there are many other tasks involved. The refund, the customer statement, customer receipt, many different tasks are involved. So you, instead of writing all those things in one program, you break them down into smaller subprograms. Or in this particular case, it's called a subtask. So the concept is called divide and conquer. The bigger problem, you divide into smaller problems because smaller problems are easier to handle. You can easily handle a much smaller problem. And then smaller tasks can easily be modified. And in fact, in the next slide, you'll see there are many benefits to modularization of the code. Some of the benefits are highlighted here: simpler code, small modules, easy to read, and one as compared to one large one. And the reusability, the code can be reused, just like for real estate we say location, location, location. For modularization, it's the reusability of the code. We can call those modules many times. In fact, if you don't have a module and you want to call the same lines of code, let's say 10 or 20 lines of code, then you will be copying and pasting over and over again. Instead of doing that, you can just put those 5, 10 lines of code in a separate module, and you can call them when you need them. It's easier to test your code, test separate and isolated modules to fix problems, fix errors, debug them, and test against different cases and scenarios. The development process is much larger. Remember, large systems are not developed by one individual, but the many team of developers. So it's actually much faster, and then you can reuse the common task. Easier facilitation of teamwork, like I stated earlier. So teamwork can be assigned. One individual can be assigned for returns or refunds, or another could be for producing receipt, and so on and so forth. So the workload is divided between the team members. And the maintenance is after the implementation of that particular system, you can continue to maintain it for a much longer period of time because smaller, simpler code is easier to maintain as compared to tens of thousands of lines of code. All right, so here's a first example of pseudocode. The pseudocode is shown here. This is a module we created. And of course, this is just a pseudocode, but we'll see how it is implemented in Java, C++, and Python just in a few minutes. But this is what module definition is. The name of the module is shown here, show message. That's a name of the module. How do I know It is a module by looking at the parentheses. Whenever you see parentheses open and close, it means it's a function, it's a module. By the way, while we are here, let me also give you different names for modules. Modules are also called functions. Modules are also called methods, subprograms, subroutines, procedures. There are so many different names we have been using historically for modules. So if you hear something like functions, it is we are referring to module. Hear something methods, that's also a module, or subprogram, subroutine, procedures. Some names we don't use them. We use them in 70s and 80s, but some other names like functions and methods and modules, we still use them for current development process. All right, so this particular module, show message, all it does is displays hello world, nothing else. This is where the module begins. This is where the module ends. And then I want to call this particular function. And of course, this function is not very effective, but at least we can learn how to call that function. So you can use the name of the function, and when you use the name of the function in a different place, in a different program, that particular module will be triggered and it will be called. Once the module is called, the control of the program is going to shift from here to here. And then it will display this line of code. It will execute the line of code here. So this is how the module is created. And this is how the module is called. You must call the module. If you do not call the module, it will not automatically be triggered. So module must be called by using the name of the function or name of the module. So name of the module should be descriptive. You should not call a module X or Y or A or B because that's not very descriptive enough, and should not be guessing what the purpose of the module is. If the module is to display the header, for example, it should say display header. There's some limitations that or some rules apply to the naming of the module. There should not be any spaces in the module name. There should not be any spaces, no punctuations, cannot begin with a number. Kind of similar to when we talked about in chapter 2, the declaration of variables, kind of similar rules as well. So the definition contained two parts. The header part, this is the header part. This is the header of the module or function. And you can see this is the name. This tells me it's a function. And in different languages, there'll be different things highlighted here. And we'll see those in Java, C++, and Python just in a little bit. So that's the header of the function. The header of the function tells me a lot. It tells me the name, it tells me if it's going to return something, it's going to accept an argument. We'll talk about those in just a bit. And this is the body of the function, body of the module. All right, so it has two parts, the header and the body of the function. All right, a call must be made to the module in order for the statements in the body to execute, which I already indicated. So here you have the show message right here. This is a module. So we are making a call show message in the main function, and then the control shifts over here, and the module will be called, and it will start running the statements within the body of that particular module. If you want to draw a flow chart for modules, so for the flow chart, you should definitely need to draw a separate flow chart for that particular module. And this is how you can show the call of the module. Notice that this rectangle and these two lines, this actually indicates this is a call to the function or call to a module. All right. The top-down design is used to break down an algorithm into modules by following the steps. So when the problem is very complex, and the algorithm is breaking down into smaller modules, when the goal is to make it easier for the development purposes. So the overall task is broken down into series of subtasks, series of subproblems. So these are subproblems. Each one of subtasks is repeatedly examined to determine if the further broken down need to be broken down. And each subtask is coded. And the subtask here is a module, basically. So you look at your entire system and you say, okay, where can I break it down into smaller problem? And then when you have broken down into smaller problem, you further look into it if further modularization is needed in that particular case. Now here, this is called the hierarchy chart. The hierarchy chart gives you the visual representation of the relationship between modules. The details of the program are excluded. So you're not showing the details, you're just showing how these modules are connected. Notice that in Java and C++ and many other languages, the main is a starting point. That's the main function, main module. From the main, notice that I have an ability to call get input, calculate gross pay, calculate overtime, calculate withholdings, calculate net pay. So these lie right underneath the. So this is a second tier under the main function. Within get input, you can see there are two additional modules. Within get calculate withholdings, there are two additional modules. So this actually gives me the detailed information or graphical representation of the entire system. So inside the module, you can have a local variable. Local variable is within the body of that particular module. It is not, cannot be seen outside directly, cannot be accessed directly, cannot be modified. And whatever happens inside the body of the function, that is called the scope. So variable scope, for example, that variable is calculating some kind of result, some kind of paycheck, whatever it's calculating, that's within the scope of that particular module. And that this will make a little bit more sense in next couple of slides. All right, so let's take a look at this module here. So here, notice that we are saying we cannot have duplicate variable names within the same scope. Scope means within the same body here. So here I declared a variable age. Notice right there, the age is declared right there. Then you're redeclaring age here. That is duplication. So it's going to give you an error message because this age variable was already declared here. So within the scope, you cannot declare the same variable twice. So duplicate variable names in different scopes can have the same name. So if when you have two separate modules, notice that there is a show square module and show half module. Now these are two different scopes. These are two different universes. They are not directly connected to each other. So, and these two functions will be called from the main function right there on the top. So the show square can have a variable name, number, for example. So here is variable name number is declared. Similarly, you can declare the same number in this particular module. They are not directly connected to each other, so that is perfectly fine. In fact, this number has nothing to do with this number, although it looks identical, but compiler knows each one of these number variables are separate from each other. So it keeps their scope separate from each other. Sometimes one or more pieces of data need to be sent to a module, and that is called passing an argument to modules. An argument is any piece. Argument is any piece a piece of data that is passed into module when the module is called. So sometimes when you're calling a module, so you have a choice passing 0 arguments, 1, 2, 3, or many arguments. So passing an argument is like passing a piece of data or message. So you can actually pass that argument and then you can receive as a parameter. Parameter is a variable that receives an argument. So when you call a function, that's where argument is being passed. When you receive that particular argument or that piece of data, that is called parameter is received. So the argument and the receiving parameter must be of the same type. And we'll see that in next slide. So you can also pass multiple arguments like I stated earlier. All right, let's take a look here. So here I'm calling show sum function right there in the main. This is my main function. So in show sum, I'm passing two arguments, 12 and 45. Notice that these are whole numbers. So then these are called two arguments. So here's my show sum function. It's a module. It's a separate module. I must capture these two values of that type. So these two are whole numbers. Or integers, I must capture them, number one, number two, as integers. I should not be trying to capture in a wrong kind of data type. Otherwise, there'll be a mismatch. Also, if this particular function doesn't have the ability to capture those two arguments, it's going to give you an error message because there's a mismatch. So if you're passing two arguments, you must have the ability to capture them. And then once these two numbers are captured, you can add them, you can do whatever you need to do, and you can return something back or display something back. So in many languages, you can only pass by value. In C++ and a couple of other languages, you can also pass by reference. We'll talk about that just in a bit, but let's talk about pass by value first. So pass by value means that only a copy of the argument value is being passed into module. It's a one directional communication. Calling module can only communicate with the called module. What it means is when you're passing 12 and 45, these 12 and 45, these two arguments still exist in the main function. They still are alive in the main function. You're just making a copy and passing those copies of 12 and 45 here. That's what it means by pass by value. So the original function has its own value, and the receiving function receives those two values. In some languages, such as C++, you can also pass by reference, which means the argument is passed into reference variable. It's a two-way communication. So exactly the same value is being passed from one function to another function. If the other function, other module modifies those values, they will reflect in the previous function. It's a little bit more cumbersome to understand, but it gives you raw power to modify the data in different function without even returning something back. And again, this probably will come back when we talk about C++ a little bit later. Now, global variables, something I really, really, really dislike. And global variables are declared outside of any module, outside of any function, and they are out there. Any function can access them and modify them, and then you wouldn't know which function did it and how it was done. So it's something we should not be doing it. We did it in legacy programming languages. We should not be using global variables. That's what the book is also saying. We should avoid them because of debugging difficulty. Module dependent on global variables make it hard to reuse module in other programs and hard to understand. So we should not be using global variables. In fact, in my programming classes, I don't accept any code, any program which they use global variables. The global constants are okay. Again, not a good practice, but they're okay because global constants cannot be modified. So if you declare something outside of the function and it's constant, which means you cannot modify the value. So that's what it's saying here. Since a program cannot modify the value of the constant, these are safer than global variables. Not all languages allow these things. So we'll come back and look into those. So let's look at the implementation in Java first. So in Java, modules are called methods. All right. Remember, we mentioned several different names: modules, functions, methods, procedures, subprograms, subroutines, so many different names. So here, to create a method in Java, you must write its definition, which consists of a header. Remember, we talked about the header. This is the header. And the body, this is the body. Body actually is within the curly braces. And this is true in many languages. As you remember, in Python, they don't use the curly braces, they use indentation. But regardless, it's very easy to understand. This is the name of the function. This is the function we are creating or method we are creating. This method is designed not to return anything. That's why it's called void. Void means this function doesn't return back anything when it was called. It is a public method and it is static. So here, all we are doing is we are displaying hello world in this particular function. All right, so let's take a look. If I want to call that function, I will simply say show message. When we call show message, this message function, show message method will be called. All right, so when a method is called, the program branches to that method and executes this statement in its body. All right, how do I pass variables? So let's say I declare in my, I declare my variable. So this is a local variable. This local variable basically exists within the scope of that module. So this my method function has a value equals to 5. It's unknown to the outside world because of the scope of this particular module, which we in the beginning talked about it. Now you can also have an argument, and this argument can be passed. For example, the display value function has an ability to take one argument. And notice that there's a parameter and number, which is a integer whole number. So it can actually capture that from outside. How do I pass it on? I think it shows me. Let me see. Uh, oh, okay. To pass an argument into a method, you must declare a parameter variable in this, which we saw. I think it's kind of duplication of that one. All right. So how do I pass it on? So when I call the display value function, so 5 is being passed on. So 5 will be captured in this number variable. Once you have that variable, and this is called pass by value because 5 exists in the previous location as well as it made a copy of itself and passed on to this number variable. Then you can do whatever you need to do in that function. You can also pass two arguments. There are two arguments of whole number type, and you can see number one and number two captures them. And then it does something locally, and this result is a local variable, and then it can display the results. Okay. So in Java, arguments are passed by value. A copy of the arguments is passed into parameter variable. If a parameter variable is changed inside the method, it has no effect in the original location, original argument, like I stated a couple of times earlier as well. In Java, global constants cannot be declared outside of a class. If you declare a variable or constant inside a class, but outside of all the classes methods, that variable or constant is known as a class field and will be available to all the methods within the scope. So here, notice that there is something declared outside here. It's something which is a constant. Constants cannot be modified. So this value can be accessed here, can be accessed here, can be accessed in these three different functions. There are three different functions. Method one, main function, method two, method three. Not a practice something I recommend, but it is easily accessible. All right, let's look at the implementation in Python. So as you remember, in Python, we don't use the curly braces. Instead, we have spaces. We have indentation. Indentation indicates this is the body of that particular function. So the name of the function is message. And notice that the keyword here, def or define, and then colon actually indicates this is where the body of the function is going to begin. And this is the header here, the header over here, and this is the body of that particular module. And let's move on. So here, I want to call this function. So this is the body of that function and header and the body, and I can call that function. Function will be called right there, and it's going to display these two statements, as you can see in the output. All right, so in Python, each line in a block must be indented, as I indicated. These statements are not in the block. So this is something you see if I say print over here, this is not part of this block. I honestly, I prefer curly braces because it gives you a pretty good view. But Python is a fairly new language. They decided to avoid curly braces. But many programming languages, they actually show the body of that particular function or module in curly braces. But here, that's what it's indicating. So here in greeting, that's where the function will be called. But before that one, there's a print. I will call the greeting function that is outside of the body of this particular function. That's what it's highlighting there, right? So this is a local variable, like we saw earlier, local variable declared within that particular function. And this is where argument can be passed. This is a values of parameter. In Python, if you remember, you don't need to give the definition for or type of the variable because it automatically detects the type of data coming in and it allocates appropriately. And so that's how you can actually receive an argument. And this is where the argument is being received. 5 will be captured in this value variable. All right. And you can pass two of them. We saw earlier as well. Two of those arguments are being passed in these two parameters. All right. Very similar, nothing different at all. A couple of other things. The arguments are passed by value in Python. Only copy of an argument is similar to Java as well. But parameter variables change inside the function. It has no effect. Exactly similar to Java as well. Global variable is created in an assignment statement that is written outside all the function in the file. A global variable can be accessed by. So here, this is a global variable, something I really dislike, and it's there. And this particular value, my value, can be accessed here, can be accessed in any other place, something we should avoid at all costs. So global constant, Python does not allow you to create the true global constants. However, you can simulate them. Again, something we should try to avoid them, but they have the ability. All right, let's move on to the last language, which is C++. So we use functions to modularize code to create a function in C++. You must write its definition. So here it is. So show message is the function name or module name. And this is the header. This void means this function is not designed to return anything back to the user. So inside here, all we are saying hello world. And then how do I call it? You can call it, so let's say this is your main function. So this is your main function here. In the main function, you're calling show message here. Show message exists right there. This is the body of the show message, but it is the signature or the header of the function is copied and pasted above the main function. The reason is in C++, it doesn't know where the function is. When you provide that prototype, it's called a prototyping, then the compiler understands this show message exists somewhere, then it looks for it. So if I do not want to have the prototype, then I have to copy this entire function above the main function. I have to have the specific sequential order. In order to avoid that sequential order, I can simply copy the header and put a semicolon at the end. That is called function prototype. All right, so here's my function. My function has a local variable 5, exactly what we saw in Java and Python. And here's an argument, number argument, or parameter in this case. And then I can pass this argument. It will be captured in this value. Then I can do something locally. And then you can also do the same thing, just like Java and Python. So exactly the same order. And you can capture two of these arguments as well. So C++ provide a special variable called the reference. This is, we saw was not available in Java and Python, but it is available. So you can notice that there's a ampersand sign next to it. What it means is whatever value is being captured in the number variable, wherever you're sending this value, it will be the same exact value. It will reflect in the both functions at the same time. So any changes made to the reference parameter variable are performed on the actual argument that was passed into the array. To declare a parameter, you use a reference or ampersand sign here. This gives you a lot of power. At the same time, it also a lot of risk involved. So it's not all the languages they allow you to do such a thing. So global constants are also acceptable in global variables and constants are acceptable. Something I recommend highly not to use them. But you can see the keyword const here, right there. And this interest rate is available in any one of these functions. All right, so we finished our chapter successfully, and hopefully this will benefit you to understand how we can break down our problem into smaller problems. All right, I'll see you in chapter number 6 shortly.